let's correct this quiz here. I'll just show you the key. So look at that. Thank you. Very much appreciated. All right. All right, so the first one, it asked for the z-score of a mark of 740. Some of you, every question was worth 2, so if you didn't do any work and you got it wrong, it was pretty much -2, right? So it actually hurt you not doing anything. So some of you mix this up. So it's x, right? The formula, make sure you have this right. In this order, you take your score minus the mean over standard deviation, and it's not 0.54, it's negative 0.54. So if you did the work, you still got 1 mark, but you lost a mark for not selecting the negative. This one, folks, in a normal distribution, find the percent of data between z of 0.5 and z of 0.163. What do we know when we're talking z-scores? What do we know about the mean and the standard deviation? Automatically, we know that the mean is 0, standard deviation is 1. And because it's asking for percent of data, we want to use normal CDF. And so you just put the start and the stop, right? This is a start, this is a stop. Always lowest first, highest second. If you don't do it, if you revert the order, you're going to get an error, right? Or you're going to get a negative or something. So you just got to watch out for that. And so that's 25.7%, which is this one right here. Make sure you follow along, write things down. This one involved 2 steps. Okay, so you know what? A lot of you did the normal CDF. You did, right? It says number lasting more than this many kilometers. So you went 57,600, and then this should have been 1,000,000, to be honest. I went with 100,000, but we're going to get the same answer. And then mean and standard deviation. And so you got the 0.97, which is the 98%, which some of you thought 98%, right? But it's the number of tires. So the 1,500, the number of tires gets multiplied by the probability that you found. So we're talking this many tires would last longer than that. So that was your answer. That was the best answer there. Okay. Notice that none of these answers, it didn't say percentage, it says the number of tires. Okay. Next. Bart wrote the test and achieved a z-score of 0.41. The test scores are normally distributed with a mean of this, standard deviation of that. What is the actual score on the test? Okay. So that's when you're supposed to, this wasn't supposed to say X, Z there, right? It's supposed to say X. Then you use this formula here. Okay, so you have to have this on your study sheet as well. I basically give you all these pieces on the right side of the equation. You just have to plug in and go. So 67.2 is your answer there. Okay, let's make something very clear here. If it says the top 5 participants, right, top 5, if it ever says top 5, we're talking, this is a very basic normal curve, right? But we're talking about the top 5 here. Okay. So it wants the, what would be the z-score, right, where you are at the top 5? So you use inverse norm, and you put in 0.95 because you want everything to the left of that z-score. And you automatically go 0, 1 because now we're talking z-scores. It's going to spit back a z-score. Okay? So 1.64 was the correct answer there. Okay, let's keep going. This one, I'm not very concerned. Some of you just need to make sure you put the percentages down and you label properly. Okay, so you got to make sure all of that stuff is in there. If I do ask you for a normal curve, if I give you that many marks, 3 marks, then I'm looking for labels, percentages. Some of you even put the z-scores down there, which is awesome. Just do it, right? You won't get docked for having that. And then some of you missed the fact that I wanted you to use the graph above, not normal CDF. Some of you are using normal CDF, which in theory is not wrong, but the province wants you to also know, can you read a graph? Okay, so this one was particularly directed towards, can you read your graph? So more than 7,800 steps, we're all obviously right here. So it's everything there to the right of it. So 2.5%. Watch this, when it says less than this or more than that, we're talking about the wings, right? This is 1,800, so I want everything here and more than 9,300, you're supposed to combine it to 2.65. Some of you just gave me these two wings separately. So just make a note to add that. And then fewer than 7,800 steps. Watch what I did. I don't know if you noticed how I went about it. Fewer, 7,800 is here. So yes, you can just add everything to the left. Or you can say, hey, this is 2.5. To the right is 2.5. I'm going to take that away from 100%. And then I get 97.5, right? I get everything that's fewer that way. Whatever floats your boat, right? You just do it your way. But I just need you to be aware of both methods. This one, honestly, by tomorrow, I want you to ace this one. Okay, some of you were, at least I'm very happy that most of you chose to go for the midpoints right away. So that's a good sign, okay? You didn't forget about, oh, I need to figure out my midpoints, especially when you're trying to find the mean and the standard deviation. So way to go here. And then you have to go L1, L2, right? So it should be one variable stats, L1, comma L2. This is the mean, 182.00 if you round it correctly, and it's pounds. And your standard deviation is 33.49 pounds. So some of you, and I just write down N. I may ask you for it. What does N represent in this particular scenario? And you might say frequency. Yeah, but what is this? Like number of bears in this case, right? So if I ask you specifically for it, you would want to say 151 bears, and that is on your calculator when you perform the regression. When you feed L2 into it, it's assuming that's the number of instances, right? In terms of your graph, folks, can I just ask you, don't use your midpoints when you're, especially when you're making a histogram. Go by these numbers right here. So you start at 100, then I go to 115, to 130, right? To 145, to 160. You're going up by 15 essentially. And the bars have to be the same width across the board. You can't have 3 boxes wide and then 1 box and then 2. You can't have that. You have to have the zipper, and you have to have a scale here that is consistent. So if I see you going up by 3 and all of a sudden you go up by 6, that's a -1, right, for the province. So, and then make sure this X is always whatever the interval is. So if this is years, if this is height, whatever, that's what goes along the X-axis, okay? So make sure you ace that, and the rest, it shouldn't be that difficult to get that one. I'm actually, the AC that I prepared has one more just for you to practice. Don't forget, hold on. Don't forget about, before I move on, there's the line plot. You remember the line plots? Those are when I give you a bunch of points and I want you to put it on a line. I'll give you a line. It's already made. You just have to fill it in with numbers, a scale that works, and then put the numbers where they belong, just dots for it, right? So don't forget about that. And don't forget about frequency polygon. You could easily turn this into a frequency polygon, correct? Are we aware of that? All you would have to do is take the middle of each bar and connect it with a straight line. And make sure you close it at the end, like it touches the x-axis at the end. That is, then you're guaranteed to. So if you know how to do a histogram, you definitely know how to do a frequency polygon. It's just one more layer on top of this. That's what I always suggest. Make a histogram, put a layer on top saying this is my frequency polygon. Maybe have a little, right, a little legend here, frequency polygon or something, and then you just do that, okay? Keep going. Page, the third page here. This one threw a lot of you off. I see where you got this mixed up. So just let's read this carefully. So in this case, we're talking about candies. The weight is normally distributed, a mean of 550 grams. This is your standard deviation. I do tell you to use technology or calculator to answer. What is the percentage of boxes that weigh at most 565.8? At most. Okay? This is your stop, folks. This is your stop. The 565.8 is here. So you got to go minus whatever, 1,010,000 here. Because you're going all the way up to 565.8 grams. This is at most. It's not at least, it's at most. So you stop there. So it's interested in all of this. So anything minus 10,000, minus 100,000 will do the, minus 1,000,000 will do best even. Okay, so why normal CDF? Because it asks for percentages. And why this way? Because of the word at most. Okay, that's the highest you get to. If the company produces 20,000 boxes per day, how many boxes weigh at most 565.8? So you should see, oh, these are related. I already figured out the percentage. So I'm going to use the percentage in A, turn it into a decimal, and just multiply it by 20,000. And your answers are all over the place. Because if you got this wrong, as long as I see you using it here, you get the mark in B, right? So that's, so if you compare with your neighbor, you're like, how come you got that? It's like, yeah, because A is wrong. Okay. This one threw you for a loop, eh? So there was an applied test that was worth 56 marks. That is actually, for now, it's TMI, too much information. Okay. The average score was 32, the standard deviation is 6. That is important to us. Find the percent of the students scoring less than 17 marks. Less than 17. So 17 is your stop. You want everything less than that, right? So first of all, it's normal CDF because it's asking for percentage of students. So it's negative 10,000 or negative 1,000,000. Stick with 1,000,000, okay? It's safer. You want to be a millionaire. Okay, anyways, negative 10,000, 17, 32, 6. 56 should not come in here at all, okay, because it asks for mean and standard deviation. It's a very tiny amount of students scored less than that. Between, this one should be a slam dunk. Between is just, I give you the start and the stop, right? Start, stop, mean, standard deviation. At the very least, I should have seen 32.6 everywhere. 32.6, 32.6, right? At the very least. At the end, the mean standard deviation. What percentage of students pass the test? A pass is 50%. So if the test is 56, half of that is 28. So 28 is like, that would be the lowest score, right? So if you pass, you get 28 or more. So that's where this comes from. And so 74.75% is the score required. Oh, sorry, the percentage of students that passed. I could now ask you how many students passed if I told you the class size. I didn't tell you that, but I could. Okay. Make sure you write this down. I'm going to post this as well, so if I go a little bit too fast. If only 15% of all students got a greater score than you, what is your score? Show that what you're punching into your calculator as well as your answer. So if 15% scored more than you, right, your score is higher up on the x-axis. So 15 is above you. That means that 85 scored less than you. That's the one I needed in the inverse norm. And then your mean and standard deviation. So 38.22 or 38, I would have accepted both. And there you have it. Russell achieved a mark of 30 on his math test. Calculate his z-score. Come on, folks. This one is just 30 minus mean divided by standard deviation. Just make sure you don't rush. Make sure there's bracket here, okay, folks? You're looking up, right? Because it hurts when I see, oh yeah, you're doing everything right, and then you get the wrong answer. It hurts you too, but it hurts me as well, right? I don't want to mark it wrong, but I can't change it. Next, back page here. The LSAT is an admissions test that students need to write to be admitted into law school. Anybody getting into law here? I'm only getting in trouble with the law, Mr. Dirksen. That's all I'm doing. I'm just kidding. The average LSAT score is 155.88 with a standard deviation of 4.97. So that's given. The University of Toronto requires a minimum score of 160 to be admitted into the Faculty of Law. Determine the percentage of students that would be accepted. A minimum of 160, so that's your start. So low and the highest, you put 1,000,000, I'm sure, if you did this. Mean standard deviation. So 20.63, 36% of students will be admitted in that case. University of Victoria, only the top 15% of students are admitted. What score must a student achieve to be accepted? So I'm giving you percentage top, right? Top 15. I'm giving you the 15% here. You want 85%. Too much 85s in this test, right? 85 is what you want to go in here. So that's where the 1 mark comes from. And then the mean and the standard deviation. Even if you had used inverse norm and used 0.15, if you had the mean and standard deviation, you still could have earned 1 mark there for using inverse norm. And then 2,200 applicants. Folks, listen to this. If I give you the number of something, like how many, then you're going to have to do some extra work, right? How many applicants at the U of Toronto, right, would be admitted to the program? You figured out in A that it's this many will be admitted percentage-wise. If you now have a number of students, you multiply them together and you get 447.92. So you can say 447, I accept 448, you're good to go. Last but not least, some of you give me a diagram, but I needed a bit more to get full marks. Please just remember this, okay? I know I loaded this thing up, like it's crazy how full this is. It didn't expect all this much. You don't even need to have yours to scale, honestly. I just want to see, do you understand what's happening? So Ms. Yosik's will be steeper, taller, right, because of a lower standard deviation. Mr. Dirksen's will be flatter, more spread out because of a higher standard deviation. Okay? Another observation I make is that class scored lower overall with Ms. Yosik, right, because of the lower mean, but scores were more consistent due to the low standard deviation. So the orange and the, like these two statements down here, that's like the minimum I would expect you to add to your description. And some of you gave me nice, like full-on sentences, even better. And for Mr. Dirksen, if you talk from my perspective, higher average overall. Okay, so overall scores were higher, but they were more inconsistent because of the higher standard deviation. So I have students like a bit more spread apart in terms of the range. So I have maybe really high and really low, right? So I've got outliers, you can say that too, basically. Outliers cause your data to be more spread out. So we're getting there. See here the little bubble here on the side? I think it's page 3 of your notes. I do talk about all of that, like what does a low standard deviation versus a high standard deviation, like I compare them. So if you just go there one more time, I would honestly say on your study sheet, maybe have something like a short little thing, 2 different graphs, and maybe honestly, even if you just had this on your study sheet on a very small scale, you'd be in pretty good shape to answer the question. Okay? All right, Now the added sheet that I asked you to staple. I was overall very happy how you did the first part. Question 7, how you set up your bins and how you placed everything. I must say that your mean and standard deviation was a little off at times, but I wasn't too concerned with that. I just saw, do you know how to set up your bins? Right, you start, make sure you know where your mean is. Make sure you tell yourself, this is my mean. Because then you're going to check 1 standard deviation to both sides, 2 standard deviations, and then 3, right? You're going to go from there to the sides. So within 1 standard deviation, right, you added the 12 and the 6. And that gave you 18 out of 28 at 64.29. It passes. 2 standard deviations, obviously you take 4 bins in total, 2 on either side. It passes as well, and obviously the last one will pass almost every time. So the fail will happen within the first 2. And so we say data is normally distributed. Make sure you tell me whether or not it is. Okay, I don't want you, don't let me guess, okay? Now pay attention to this one, because 8, 9, and 10 were a little bit of a challenge. When it comes to, listen carefully, when I ask you, I give you 2 classes or 2 different scenarios and I ask you who did better, your best bet is to find each of their z-scores, okay? And in this case, it was so obvious, I mean, right? Gabrielle is the one that wins because of the higher z-score. Just be careful you don't think it's the highest is always better. It is in this case. When it comes to grades, yes, z-score is always better. Okay, but just look at the context and you should be fine. This one is on page, I want to send you to the page if you need a refresher on this. Page 51 in your booklet. So I will actually put a note down here. Page 51 in the notes. Look this up. Page 51 in your notes. That's where I get this from. Okay? I'll try to fit this in, but basically, folks, I always start with the standard deviation first. It's high, upper minus lower value, and then z-score up, z-score low. And ends up being 0.5. Where did I get the z-scores from? Mrs. Rickson, I'm confused. Where did you get your z-scores from? How did you know it was -2 and 2? It was because of this. 95% of students. Okay, that's you. That means that this is your mean, correct? 95, we're talking 2 standard deviations this way, 2 standard deviations that way. So it's telling me that if I see the 9 to 11, that age, that means that 9 goes here. This is the low. And the upper goes here. Okay, the upper goes there. So this is Z low and Z up. 7 up. Hey, they don't pay me to say this. Anyways. And then I found the standard deviation first, 0.5, and then I found my mean using this formula right here. This formula allowed me to find that. Mr. Erickson, could I have just gone up by 0.5 until I get to the mean and then come up with 10? Yes, absolutely. 9, right? 9.5, 10, 10.5, 11. In fact, you should be able to check your standard deviation and get from one to the other by jumping those standard deviations that you've decided are in between them. Okay? Backside. Backside. This one, I've done on it, the Hippo AC has it. I'm not sure where else you will find it. But just make sure, if it says the middle 50%, if this is a normal distribution, the 50% goes here. that means that you still have 50 to be distributed, right? And that gets split up equally between both wings here, 25, 25. So you do, for the x1, for this first one, use inverse norm, 0.25, mean standard deviation, so you get this many hours. For that second x, you got to add 50 and 25, so that's 75% to the left. That's 2.67. Okay, so there you have your low and your high. That's the hours in between we're talking about. Okay. All right, so I'm going to stop there.